Okay, welcome back. In this episode, we are gonna add weight to um our linear impulse. So that, for example, a rigid body with a weight of 100 is going to be well, it's not that much moved than a shape of just a weight of 10, for example. And we can do that quite simple. We will add, after the relative velocity along normal check, we're gonna sum up the inward mass, and I'm gonna call this inward mass sum. It's equal to this dot rigid body A dot inward mass plus this dot rigid B dot inward mass. And we're gonna use this inward mass under the calculation of the impulse, and we are dividing the impulse by the inward mass. Okay. Also, we need to scale the velocity. Sorry, for the impulse vector reaching a velocity with the mass. And we can do this by just replacing the 0.5 with this dot Ricci A dot inward mass times -1, and the other one, this dot Ricci B dot inward mass. Yeah, that's it. Okay. I think that's already everything we need to do. Yeah. Then I'm gonna set a different mass. Also, I'm gonna change some things right here. I'm gonna change the size of a rectangle. Gonna set it like this, 300, 300, and I'm gonna say, oh yeah, I just want to have this circle at the last position. I'm gonna set the coordinates of this circle also to something else, to 900, 300, and the first rectangle I'm gonna set it to 100 and 600. Second rectangle I'm gonna set it to 600 and 400. And I'm gonna set the size of the first rectangle to 200 and 100, the width and the height. Okay, and I think that's everything. Yeah. All right, then jump back to the browser, refresh. And okay, I'm not sure. Did it do something? Yes, it did. All right. Oh, I might make a error there. Yeah, right. I want to have I wanted to have the second rectangle. It says of 300 and 300. And now I have everything in place. There we go. And now I'm gonna use this rectangle, this small rectangle. Oh, I forgot to set the weight, the weights. All right. I'm gonna set this big one to 100. This will have a mass of 100 and the other ones of 10. Okay, so finally, I'm gonna use this rectangle and throw it against the big one. And there we go. The small rectangle is bounced off the bigger one pretty fast, or faster than the really, really large one. And that's the exact behavior we want to see. Very nice. Cool. Here again. Very cool. Okay. What if we set the weight of one from the big rectangle to 0? Let's see what's happening. Yeah, the big rectangle doesn't move. That's the exact thing we want to have too, and that's quite neat because the inward mass of this one will be 0, like we did here. If the mass is 0, then we're going to set the inward mass to 0. And what is happening now is, if you look into the collision manifold, you can see we are using here the inward mass sum. One of the bodies will be 0, so that's fine. It's not a divide by 0, only if both shapes are 0. So we have a problem if we compare two shapes which have a which have the same weight, and like the same weight will be null, then we have the problem that we're dividing by 0. We will catch that case before we're doing any divide by 0 things. And yeah, well, this value here will have a non-zero value. That's okay. But if we do here something, this one, for example, if which the A has a mass of 0, so the inward mass has a mass of 0, and the multiplied by -1, it will be still 0. So that means that the impulse vector will be 0, and the resulting velocity will be 0. Okay, this one will be just 0, so it's not going to move anywhere. Yeah, and that's it for this episode. In the next one, we will add kinematic bodies. So that will be these checks before the division by 0, and some other things in the rigid body class. Okay, so that's it. See you in the next one.